Okay. So it's just I designed this presentation with very basic aspects. So it will be helpful for beginners who are starting in an academic lab setting. And I know there are lots of experts here, like postdocs and research scientists. So please contribute. This is just going to be like a discussion. So if I miss anything in my presentation, please feel free to contribute. Okay. So the objective of today's presentation are to provide some basic guidelines on best practices in a lab environment, and also to have some basic ideas on do's and don'ts in a lab setting. It is very helpful for beginners in the lab to be aware of that. So why do we need to follow best laboratory practices? First of all, when we follow best practice every day, it becomes like a kind of a working habit. And if you have a good working habit, it is very helpful for us all through our research career. So the research is always evolving, and every day we are learning. So it's always to have a best working habit. So and also it's important to have like best practices, because it gives safety for the person who is working and also other people who are working with you. And having best practices also helps us to minimize errors when we are doing the experiment, so we can generate quality data. And also it's important to have reproducibility in our data so that we can generate reliable data with our experiments. And more importantly, it's like a best value of our time and resources. So if you minimize committing mistakes and errors, we don't need to repeat the experiments again and again. So we don't thereby we can conserve our time and also the resources that we use in conducting the experiments. So the first I wanted to say a few things about the safety aspects. Then I will touch on the experiments, how we set up the experiments, and what things we need to remember. So with regards to the safety aspect, it's we have to remember to follow the laboratory rules. It will be different from one lab to another, and we have to follow those rules. And also, it's important for us to keep in mind the university, the EHS policy, the environmental health and safety policy, and we need to follow whenever and wherever it is required to follow. And we should wear the proper personal protective equipment, like having the lab coat and toe-covered shoes. It's always good. And also wearing gloves wherever it is necessary, and having goggles to protect ourselves when we are handling like fixities and corrosive reagents, just to as a protection measure. And also it's important to remember how we handle the chemical waste and how we use the fume hoods, because like we cannot dump the chemical waste in all like regular sink, and there are designated containers where we need to dispose them. So if you're not sure, okay, if you're using a chemical and if you're not sure what to do with that, you can always check the label on the bottle, and then accordingly you know whether it's a hazardous waste, and you have to dispose it accordingly. And also when we are using the fume hood, like for certain reagents, like like xylene, and when we do fixities, it's important to prepare them and use them in the hood. And also when we are using like sharps, like razors, blades, when we are using the animal work, and then we use like needles and with syringes with needles, after using, we should not dispose it into regular trash can. It needs to be disposed in a proper containers designated for that. Okay. The same with the broken glassware also. We have to be careful not to dispose of it in the regular bucket. And the waste from animal work, most of our lab, we deal with animals, right? Like, so when we are working with the animals, like blood-stained tissue towels, swabs, and everything, we should not be disposing it to the a regular trash can. There are designated biohazard containers, and we have to dispose them there. And also with animal tissue waste and also carcasses, again, we should be careful where we are putting them. So in general, we in the labs, like we have a temporary storage place at minus 20 in the freezer, and then once we collect and take it to the central storage by. Okay. So these things are very important, and we have to adhere to the policy. And also we should be, remember to avoid having food or drink at your workbench. And also in the designated lab areas, which has like a biohazard labels. Okay. And whenever you are using the biosafety hoods, we have to make sure to have the proper personal protective equipment, because the biosafety hoods, we use it for the primary cell lines and cell cultures. So we need to be careful enough, because these are very vulnerable to get contaminated, and they're very precious. And we have to make sure that we are maintaining also a sterile working environment. Right? And mistakes happen, and if you're spilling or breaking, if there are any broken items around, it's important to let the people around to know about it and make sure that you clean them immediately. And it's also like, valuable, like if you're working in any new lab setting, to know where all these emergency equipments are, like the first aid kit, eye wash area, and everything, just to be conversant about it, so that when you're working alone in the lab or something, it's always helpful, and it's a proactive protection measure. So next, I wanted to touch a few housekeeping aspects that we can would be very useful when we're doing the experiment. It's always helpful to have a clutter-free workspace, so that we can, whenever we are doing an experiment, like sometimes the experiments they go for several days. Also, like having a clutter-free workspace always helps us to have a smooth workflow. So, and whenever we do an experiment, we remember to clean up after the bench work, and also dispose the trash appropriately. And also washing the glasswares and tools that we're using is also an integral part of finishing an experiment. And more importantly, when we are using common areas, we have to be, like after working, to leave the space clean, so that we are making sure that for the next person, the space is ready to use. So some of the common areas in the labs are like the place where we do the animal harvest, tissue harvest, and those areas, and fume hood, like where we do the histology stuff. And also in the histology course, we have the cryosectioning machine and the microtomes, and whenever we are using these machines, make sure like cleaning up and removing the blades and not leaving the tissue blocks there. And those things are some of the things that we have to keep in mind, so that it helps us to preserve our samples, and also when the next person is coming, the lab space is clean for them to use. And also like the weighing areas and the pH meters, whenever we are weighing chemicals, and if there is any spillage, it's better to clean and make sure the scales are switched off. And also the pH meters, the electrodes are very sensitive. Sometimes they come with a special storage solution where we need to heat the electrodes. And it's better to keep these things in mind whenever we are using these things. And cell culture biosafety hood, where, as I said earlier, the biosafety hood we use for cells, right? And they're very vulnerable for contamination. So we have to maintain a sterile working environment, and more importantly, after you finish working, make sure you're cleaning it appropriately, and also appropriately you're disposing the cell culture waste. And sterilizing, with the washing the tubes, where you're collecting the cell culture waste with 70% ethanol, and the lab rules, like I'm sure, like when the new students are coming, whenever you're getting trained, you will be taught about that. It's also important to keep them in mind whenever you're working. And also the microscopes, we use it constantly, and after using, it's make sure to switch off the microscope and properly cover it and cleaning up the workspace. So next, I wanted to touch on some the experimental aspects. Okay, whenever we are designing an experiment or doing an experiment, there are major steps that we have to keep in mind. So designing planning on an experiment or designing a proper experiment. Okay? And then once we finish the planning and designing, and then we execute the experiments or run other experiments. And after that, we document the results. And then we do the analysis of the results. And based on the analysis and results, we interpret and draw conclusion and ask for the questions, how to move forward. And then we plan on the next step. And also, like, it's important, the communication. The communication involves, like, whenever you are finishing an experiment, you can, we have to prepare a report, a PowerPoint presentation for communicating with your colleagues and others. So whenever we are designing an experiment, it's important, like, you have a research hypothesis, to have clarity on the research hypothesis. This is important because this helps us to design the right experiment for the questions that you're asking. Okay, so the research hypothesis always starts with having an idea in your mind, or you suddenly have a question based on something you're observing. And then once you have an idea or the question in your mind, then it's always better to research on that idea. So, usually we do that with the literature search and, previous papers published on the work or the question that you're asking. So this is important, or helps us in a way that, fine tune our questions. And also, like, sometimes we don't need to reinvent the wheel if somebody has done already the thing that you wanted to do, and it helps us to have more clarity. And but having done these prior, background work, we can have a clear hypothesis what we want to test. And then sometimes, the research hypothesis we can't answer with one experiment. We need to do multiple experiments and have to tackle that from several directions. And then in such cases, we have like a specific aims, and we plan experiments to answer each aim to ultimately answer the hypothesis or validate the hypothesis. So, and also, like, before starting an experiment, having a plan is an integral part of the experiment. And this helps us in several different ways. Like, once you go to the bench and then you do the experiment without any plan, that becomes more exhaustive because, and also like it prones us to commit a lot of errors and mistakes. So it's better to have a plan, at least in the beginning days when you're doing an experiment, become very, very familiar and a lot of experience is a different thing. When you're beginning, it's better to have a clear clarity on the plan on what experiment that you want to do. And make sure that you have appropriate controls and replicates to fulfill the statistical requirements. And also having a plan, it also helps us, we have several different reagents that we need to use. Sometimes some of the reagents, the stock would be very low, that won't be enough for the experiment that you're planning. And if you have a plan, if you plan beforehand, then you can check if all the reagents are available or if you need to order something and stuff like that. So also some experiments, we need to book equipments, we need to have a cell sorter or, use a microscope. And if those things are, commonly shared. So if you have a plan ahead, then you can book all these equipments ahead. Experimental example. And whenever you're doing a new experiment, it's better to go through the protocol. It's as I said, some experiments runs for 2 days and 3 days with several different steps. Going through the protocol gives a clarity what you're doing. And most of the experiments, like they have incubation times where we can work on our calculations on the reagents and dilutions and everything. And sometimes it may not be the case. So if possible, work on the calculations on the dilutions that you need to use for the experiment and have that in place so that, when at the time of doing the experiment, it's very easy for you, to navigate the steps. And it's also helpful to prepare a checklist that you need to follow during the protocol. Here I'm just giving a simple example, for example, like if you're planning an immunostaining experiment with 4 kidney sections on a slide, and you wanted to test like a kind of an optimization experiment, or just check 3 different antibodies, then it's better to have a template. It may not be even you can write it on your lab notebook and have it in place. So you're testing 3 different antibodies, A, B, and C, and you know which antibody goes to which section beforehand, so that while you're dispensing the antibodies, you don't need to, you'll be having a clarity. And so having this kind of template helps you, and also like a checklist. When I'm saying, even you can type the protocol and have that as a checklist. So for example, here this is the first day of the immunostaining protocol, and it has several different steps. And once you complete each step, maybe you can have a tick mark like that. So you don't miss the sequence of events, and you'll be sure that what you're doing. And these things helps, whenever you are doing a new experiment, or you're still becoming conversant with the steps. And it's also important to minimize distraction while we work at the bench, so that we can have our undivided attention in what we're doing, and this helps greatly in minimizing the errors. And some pointers on when you're preparing the reagents. Whenever you're opening a new stock, it's better to label the stock so that it is helpful for us to know when this bottle is open, whether it is past the expiry date, and etc. And it's also important we maintain the reagents at appropriate temperature during that. So we use some of the enzymes and the antibodies that we use. We always have it either at -20. Some of the antibodies we always refrigerate. So those things, when we are doing during experiment, it's better not to leave them on the room temperature. It's better to maintain them on ice, and also immediately transfer it back to the storage temperature as soon as we finish working. And these things will help us to prolong the shelf life of the reagent that we are using. And also these reagents are very expensive, so we have to keep in mind to maintain them at the appropriate temperature. And also to avoid cross-contamination of the stocks. And most of the stocks in the lab, it's not for one person use, it's for everybody's use, right? So if you're having 2 or 3 antibodies, when you're pipetting out from one vial, it's important that we need to change the pipette tip and not using the same tip for the other vial. Then you cross-contaminate, and by mistake, then that would kind of amplify with everyone's work too. So those things we have to keep in mind. And buffer preparation, we have to follow the protocol. Some of the buffers are very simple, and some of the buffers are complex. We need to add several different salts, and so it's always have the protocol, follow the protocol, and make the buffers. And label them with the concentration and the date of preparation, your name. So it is helpful to know, because some buffers, they have shelf life. They can be used only for a certain period of time, and then you have to make a new buffer. So if you have a date and everything in there, it's always helpful. And also remember to store them at the appropriate temperature. And also we have to check the buffers before we use, because sometimes some of the buffers, if you're having like a triton and tween and all, they become have precipitates, and so those things we have to see before using. If it's past the expiry date, your buffers. In that case, you have to make fresh buffer and use for the experiment. So once we finish the experiment, like, we generate results. Okay, the generation of results, there's different ways. Sometimes we do the imaging, and sometimes we do quantification, like, so there are several different ways that we analyze our experiments. Once we analyze, then we will be doing statistical analysis to see the difference between the treatments that we're using. Jason will be handling the statistical methods in one of the sessions. Okay. And once we have the results, then we have to interpret and draw conclusion out of the result. And sometimes the conclusion, we can wrap up on a particular topic with one experiment, but sometimes it leads to more questions from the results. And based on our conclusion and the questions that we are having, then we will plan the future direction of the project. So next, few aspects on documentation. Documentation, there are several different levels of documenting. So one is like, taking notes during training. It's very, very helpful. Like if you're following a new protocol, or if you're getting trained using a new equipment, it's always helpful to take notes during the training period, so that you can refer back to it when you need to do the particular technique or handle an equipment by yourself. And also documenting in the lab notebook is very, very important, and it acts as a reference material for you and also for others. So whatever the things that you are doing for an experiment, like like I was saying, preparing the checklist and having the template, everything you can paste it on the lab notebook. So it acts as a reference for yourself. Like if you want to repeat that experiment on a different days, then you can go back to lab notebook and see. And if the experiment has worked well in this condition, then you can follow the same condition and stuff like that. And also like update the lab notebooks with your results and conclusion and the data that you are generating, and also you should document where you're storing your samples and also where you're storing the experimental data, so that you will also remember when you need them. So to have a list of them is always helpful. So this by summary slide, like we have to do the best science by following best laboratory practices every day, and also being compliant to all the safety rules. And so this will help us eventually do the best research. So thank you for your attention. And yeah, now we can discuss, like, if I'm sure I would have missed several things that so we can now discuss further. Thank you. So far, yeah.